Welcome, Calculus AB. This lesson is 3-4, Implicit Differentiation. Let's begin. So, I want to talk about two different types of equations. These are explicit equations. So, equations in the y equals form. This is what you've mostly seen. So, like y equals x squared, y equals x over x minus 1. Y equals form. Sometimes it's f of x equals form. That's the same thing. These kind of equations explicitly express y in terms of x, like y equals this. Can you derive these equations? Well, yeah, of course you can. The derivative of y equals x squared is y prime equals 2x. Or this one would be quotient rule, or this one would be chain rule. These are things that you've done before and you could do right now. Now, I'm going to talk about implicit equations. So these implicit equations, where they have x's and y's, but it's kind of mixed up. So it's not y equals form, it's something else. Like x squared plus y squared equals 1. This is the equation for a circle with a radius of 1. Or this weird thing where there's two y's in there and one of them is being squared. Or just even x times y equals 1. This is not a y equals form. So these are all in what we call implicit form. The relationship between x and y is only implied. I'm not saying y equals this, but you know, like sometimes you can rearrange these equations. So like take this one. I could divide both sides by x and I would get y equals 1 over x. This is the explicit form of this implicit function, but you can't do that in every case. Because this one, you couldn't isolate the y, and you can't really do it over here because it would still be a function. It'd make two functions. So you can't derive these as is right now because it doesn't follow our rules. You can't just say, oh, like that's weird from what we've done so far. So we have a different type of differentiation we call implicit differentiation. So in implicit differentiation, it's a few steps to do this. So we can derive it, it's just done in a different way. So what you want to do is differentiate both sides with respect to x. That means do a d dx, just do your normal derivatives. But the difference is when you're deriving a y, you have to put like a times y prime at the end. Think of it like chain rule. So you have to change a times a y prime or times a dy dx at the very end. And then you start then the whole point is to isolate the y prime or isolate the dy dx. So the goal here is differentiate this, and whenever you derive the y's, you put a times a dy dx, and then you want to collect all the y's, dy dx on one side and factor out, and basically you're just isolating the y prime. So the big thing to get from this is when you differentiate the y's, chain rule a y prime or dy dx at the end. Now, I think you just need to see some examples of this. So let's do this. Let's take that equation x equals y squared. That was one of those we showed above. So what I'm going to do is I'm going to derive both sides. So the derivative of x is just 1. Derivative of y squared, so a variable squared, would be 2 times a y. Then you got to go times dy dx at the end because you derived a y. Now my goal is to isolate the dy dx. So I am going to divide both sides. To isolate that dy dx, divide by 2y on both sides. These will cancel out. So I get my dy over dx is going to equal 1 over 2y. And that's an answer. So this is what we're looking to do with these kind of equations. I'll take another example. I'm just going to write it out. It was x times y equals 1. You saw that in the past ones. And I said I could rewrite this as y equals 1 over x. Now, if you tried to... Now, let's just do our implicit differentiation of this guy. Since this is an x times a y, I actually have to break this up using the product rule, where this is my f side and this is my g side. So my f prime would be 1. My g prime, the derivative of y, would be 1 times dy dx, or just dy dx. So as you derive this, it's going to be 1 times y, just f prime times g, plus regular fx times g prime dy dx equals 0 because derivative of 1 is 0. Now, let's try to isolate the dy. So I'm going to rewrite this as y plus x dy dx. Just get rid of that 1. And I want to get just the dy terms on one side, so I'm going to subtract y on both sides. So I get my x dy dx equals negative y. Then you want to isolate the dy dx, so I'm going to divide by x on both sides. And what you're going to get is your dy dx equals negative y over x. And this is the way to derive that kind of equation. I did that right. Yeah. All right. Let's do some other examples. Let's say this one, a little messier, find y prime. Now you can write it as y prime or dy dx. I don't care. I'm going to write it as y prime this time, just because. So derivative of 2x, or x squared is 2x. And this will be minus 6y squared times a y prime or dy dx. I'm going to write y prime this time. And then plus derivative of 3x is 3 equals 0. So now I want to isolate the y prime terms. It's this guy. So I will subtract the 2x and 3 on both sides. When you do that, these cancel. Then I'm left with negative 6y squared y prime equals negative 2x minus 3. Again, isolate the y prime, so I divide by 6y squared on both sides. And I can write my y prime, since these all cancel, equals negative 2x minus 3 over negative 6y squared. Yeah, I'm sure I could simplify that in other ways, but that's good. So that's what I'm looking to do. Now, I might have to do the second derivative. And so sometimes we do the second derivative, we have to answer it in terms of y. So it means just derive it twice, right? Well, let me show you what that looks like. There's some little trick here. So I'm going to derive this, implicitly derive. So you get 2x plus 2y times dy dx equals 0. I want to isolate my dy dx, subtract 2x on both sides. So I get 2y dy dx. I'm just not showing all the work now. And then you divide by 2y on both sides. So I'll divide by 2y on both sides. These twos actually cancel. So I get my dy dx equals negative x over y. Okay, cool. That's one. But now we have to find the second derivative. So I'm going to derive this guy again. As you derive this guy again, remember it's a quotient rule. So that's my f and g. So my f prime would be negative 1. G prime would be, I'm just going to write y prime. I'm just going to mix this up. It's just 1 times y prime. So writing my second derivative, d squared y over dx squared, is going to be f prime, so negative 1 times regular g, y, minus regular f, negative x, times g prime, we'll say y prime, all over g squared, so y squared. All right, so there's my answer, sort of, right? But I want to have it in terms of y. That means I got to get rid of this y prime. That's bad. But we already found out that dy dx, or y prime, equals this. So I'm actually going to substitute that in for the y prime. So my final answer can look like this. Negative y, minus minus becomes plus x times negative x over y, instead of that y prime, over y squared. And maybe there's a way to simplify this, but we're good. All right, that's going to be it. More in class.